Today I will continue from what we had last week. Last week we went up to step 5 with examples. So today we will incorporate this step 6 into our examples. Now before I forget, next week we have Black Friday, so no class. But I would like you, if possible, I would like you to watch the YouTube video from summer. Let's see. Which one should you watch? Yeah, 2 weeks later, I will basically go over the similar thing, but I hope I can go a bit faster. So this one, Summer Math 227, West LA College. And then you will watch the one toward the end. Let me see. Wonder what is this? So basically it's this one here, the one I went over. Yeah, so on July the 20th and then July the 22nd one. Let's see. Yeah, so July the 20th and July the 22nd one. Let me write it here before I forget. So watch. Summer 20, Math 227 at West LA College, Elementary Statistic. The one dated July 20th and July 22nd, especially this one. Okay, now come back here. I will basically redo this question 1. We did question 1 up to step 5 last week. And then I will incorporate step 6 into this question 1. Let's start. Principal at the school claims that the average IQ of students in his school is above 100. That's the claim. The average IQ of students in the principal school is above 100. So that's the average, right? The average is above 100. Now, because it does not have equal sign, then when it comes to the hypothesis, it goes to the alternate hypothesis. Hypothesis, null hypothesis, alternate hypothesis. The one without equal sign will go to alternate hypothesis. Mu is greater than 100 and mu is less than equals to 100 as the complement. Now, our textbook will say the null hypothesis to be mu equals to 100, and if that's the style you use, you're okay. Now, I want to put more details here that the claim is here, the alternate hypothesis. Okay, not always though, the claim is not always alternate hypothesis. It depends on if, oh, you know what? Hello? So I put a red note there that the claim actually goes to the alternate hypothesis. Now the one I write in red is not necessary. Okay, so when you do your tests 3 weeks from now, and you need to write your hypothesis, you only write the one in blue. The one in red, if you want to write it, it's good, it's okay, but if not, that's also fine. Now I go on to step number 3. Step number 3, let's see what I have here. The sample size is 40. The sample mean is 112.5. And overall IQ score has standard deviation of 15. So sigma equals to 15. The significance level is 5%. Okay, so step 3, test statistic. Z equals to, I use C because we know we are testing for mu and the sigma is known. So the sample mean 112.5 minus 100. This 100 is from here. The constant of the null hypothesis. Okay. And then over standard deviation divided by square root of 40. So what is my test statistic? I get 5.27046. That's my step 4. Step 5. Step 3. Step 4, let me write here. Try to squeeze that in. Step 4, the p-value. Now from step 2, we see that this is the parameter is greater than a constant, so it will be a right tail test. Okay, now this is the test statistic. And the p-value is the area of the tail. Okay, to be more precise, the tail has to be going to the right. Right tail. How do we know it's right tail, Thomas? Because we want to show that the mu is greater than 100. Greater in the sense that it has to be significantly greater. So the tail will go to the greater side. Then the p-value is, oh, please don't write it this way. This p-value here is the title for the step. Okay, please don't write p-value equals to blah, 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 like that there. No. I know what you mean, but that's not the correct way to write. This is the title. Now then the p-value here will be equals to normal CDF, the area of the tail, right? From the test statistic 5.27046, and then E99 01, because that's a standard normal, right? And then you use your calculator, normal CDF of that number. I get 6.81784 times 10 to the negative 8. So that's 0. The 6 is at the 8th decimal place. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, but if we round it to 5 decimal places, this is practically 0. Okay, now then step 5. Informal conclusion. We see if the p-value is less than alpha, then we will reject null hypothesis. Okay. The fifth step, step number 5, is always about the null hypothesis. Do you reject null hypothesis or fail to reject null hypothesis? Now, in this case, because the p-value is less than alpha, we'll reject null hypothesis. Okay. Now, then, when we go to step 6, let me do it here, conclusion. Now, let's review a little bit what the conclusion is supposed to be. We saw this last week. The wording is not strict, but there are some no-nos. First one, we will not use I or we. Second, we will not use the word proof. Okay. The common wording, will be there's enough evidence, sufficient evidence, or the sample data support, or the sample data not support, so on and so forth. Okay, now let me teach you how to do the simple conclusion first, the one that the minimum accepted in my class. In my class only. Yeah, the simple one, simple version. And if this is what you do in my test, you're okay. In the simple version, I usually say this, at 5% significance level, the sample data support or does not support the claim. Okay, let me leave it here for now. In red, support or does not support. We will decide that later. The claim that now, once you say the claim that, then you need to continue with whatever you write in step 1. Whatever you write in step 1. Basically, you copy paste that. Basically, you copy paste this. Okay, let me put it out there. Now, so how do we know does the sample data support or does not support? Let's look back. Let's look back. According to step 5, we will reject null. We will reject null hypothesis. Now, if we reject null hypothesis, then we will support alternate. Is it right? And where's the claim? Is the claim with the null hypothesis or with the alternate hypothesis? Now, the claim is here. So we will then support the claim. We will then support the claim. Okay, now, Suppose I change the informal conclusion a little bit. If I change the informal conclusion saying that it is fail to reject, if we, in step 5, we have failed to reject null hypothesis, and it means we don't reject null hypothesis, then we do not support alternate. But because the claim is with the alternate hypothesis, then we do not support the claim. Okay? I think I should use an S here. Yeah, suppose it's in step 5, we reject null hypothesis and the claim is with the alternate. So maybe I use this color here. Suppose I reject null hypothesis and I support the alternate, and the claim is with the alternate. Then I will support the claim. Okay, now suppose I fail to reject null hypothesis. Fail to reject null hypothesis. Therefore, we do not support alternate hypothesis, and the claim is with the alternate hypothesis, so we do not support the claim. Okay. Now, the one I tell you here is the easy version or the simple version of providing conclusion. Now, if you want to be more, sound more professional, which I hope one day you have that, more appropriate. I will say at 5% significance level, there is sufficient evidence to support the claim that the average IQ score of students in principal school is above 100. Now, how about the wording if it were failed to reject null hypothesis? If failed to reject null hypothesis, then we will say there is insufficient evidence to support. Okay. The word support the claim is used when the alternate the claim is with the alternate hypothesis. Maybe I write it as a little note here. Little note, maybe underneath here. So we are done with that. Okay, with the claim is at the alternate hypothesis, then the wording is try to support the claim. So you will say there's sufficient or insufficient evidence to support. There's enough evidence or not enough evidence to support. Now, on the other hand, if the claim is with the null hypothesis, then the wording will be to reject the claim. Either you have sufficient evidence to reject the claim, or you have insufficient evidence to reject the claim. Okay. If you read different textbook actually give different wording. So even our textbook seems to be quite strict in the wording, but it is actually not that strict. It is actually not that strict. Okay. not that strict. As long as you are clear that you don't use the word I, you don't use the word we, and you don't use the word proof. Okay, you don't use the word proof. Let me mention something about this election thing. Okay, note. I forgot which state is that. Let's say Michigan. Michigan. In the evening, or I think it's already November the 4th. November the 4th. They suddenly find 180,000 something votes, all or mostly for Biden. While prior to that, Biden only get approximately 48%. So P equals to 48%. Now then, what is the probability? What is the probability that of 180,000 votes, most of them actually go for Biden? Most of 180,000 votes for Biden, while the probability that a vote goes for Biden is less than 50%. What is the probability for this to happen? The probability is extremely, extremely small, but it doesn't mean it cannot happen. Okay, doesn't mean it cannot happen. The probability is super small though. Of course, I myself will question that. No, how come? But do I have evidence to say that's wrong? No. Okay. The probability itself is not the evidence. It's just statistically speaking, then, yeah, you know what? I will suspect some fraud. Okay, but suspicion is not evidence. Okay, that's a statistic point of view. Okay, so if in the end they don't find any fraud, what can I say, right? You know, I just say that I suspect, for example. Okay, so is it possible that this really happened? It is possible. How possible? Very, very low, next to zero, but doesn't mean it cannot happen. Okay, just like many years ago, many years ago, I love my, for example, again, I love my mom so much, and then all of a sudden one day I talk shit about her to somebody else. Have you ever done that? I hope not. Right? But I mean, okay, what we call something impossible to happen, it does happen. Okay, so the argument to say that there for sure is a fraud is something those who claim there's a fraud supposed to provide evidence on. Okay, now, this is one example. The emphasis is how to do the conclusion. Okay, the emphasis is how to do the conclusion. You can just do the first one if you don't want to think hard. The sample data support, the sample data does not support the claim. And make sure after you say the claim, you go on with that, repeat whatever you say in step one. Do not deviate from what you said in step one. Do not change the wording. Do not change the wording. Another way, if you want to be more appropriate, and that's what it is supposed to look like. Okay, now you will see the scheme basically as the following. The scheme of hypothesis testing. Step one, you do the claim. From that claim, you develop a hypothesis claim, and then you go to hypothesis. From that hypothesis, you do test statistic. And then from test statistic, you get p-value. Now, your step 5 actually address your hypothesis, especially null hypothesis. That's informal conclusion. and your step 6 supposed to address your claim. Okay. Now, how do people cheat? How do people cheat? And you see how some statistician knows how to cheat those who don't know how to do statistics. They claim one thing, they conclude another thing. For example, the claim was about the average IQ score of a principal school is above 100. Okay, and then the conclusion later on, in this case, the conclusion seems to be true, right? Okay, the conclusion later on is about the principal. The principal was correct. No, it's not. The principal make that claim, and the data actually support that principle, but it doesn't mean that principle is correct. No, it's just the sample data support. There's no evidence otherwise. Okay, does it mean that the principle is the principal's claim is true? Well, it is supported by data, but doesn't mean that he's right. The data happens to be supportive. Okay, that's one. It doesn't say that the mean is above 100. It's just say that the sample data support that claim. Okay? And it doesn't say anything about the principle. We're talking about the mean, the average IQ score. We are not talking about the principle being right or being wrong. No. Okay, so one place that people do the cheating part is actually the claim is one thing. Once the claim not being supported by the data, then they blame the person who carried the news, which the principal just say something. Okay, and you were testing about that claim. You are not testing the principal. Okay, so don't blame the principal, even though that's what the principal claimed. Okay, so nothing personal here. Nothing personal here. That's one. Let's do the second question from last time, or should I do variation from here? Maybe I do variation from here. Give me a second. So far, our null hypothesis, our claim always goes to the alternate hypothesis. Let me change the wording a little bit such that the claim actually goes to the null hypothesis. Let's see question number 2. But I want to change the wording here. Instead of score higher than, I change that to be at least. So step 1, claim. Suppose we want to test whether or not girls on average score at least 600 on the SAT verbal section. Girls on average score at least 600 on the SAT verbal section. Step 2, hypothesis. And we see that when we say at least 600, so basically its mu is greater equals to 600, right? Now contrast this to what we learned last week. Let's see. Last week we have this one. Last week we did the higher than. Because it's higher, then it goes to the alternate hypothesis, right? Okay, that's what we have last week. Now, because we make it at least, when we make it at least, it has equal sign now. Therefore, because it has equal sign, it goes to the null hypothesis. This is the claim now. Okay. Textbook says that, let me use green. Textbook says you can still use mu is equal to 600, even though then you will see the weakness of the newer method. In this case, the claim goes to the null hypothesis. Okay, and then the alternate hypothesis will be mu less than 600. Now, from the alternate hypothesis less than 600, then it will be a left tail. Now, I hope you see the big difference between once you change at least and compare that to higher than, you see this big difference. Okay, so when you say that the score, the average is higher than 600, you need to come up with a sample mean that is significantly greater than 600, not just a bit over 600. If it is greater than 600, right? Okay, that's the claim. Now, the claim in this version here, the newer one here, is at least 600. So you may come up with a sample mean that is slightly below 600 and you still cannot refute this claim. Okay, because of this phrase being changed to be at least. Okay, now let's go on. Step 3, test statistic. Z equals to, let's see, what do I have here? Sample size is 100, sample mean is 641. Population standard deviation is 50, is 100. I'm sorry. No. The sample is actually 20. I read it wrong. The sample size is 20 with sample mean 641. The alpha is 3%. So this is 641 minus 600 over 100 over square root of 20. I get 1.83358. Step 4. Let me do it there. Yeah, let me do it here. Step 4, the p-value, standard normal distribution looks like this. If this is 0, this is 1.83358. But from our step 2, we see that that's a left tail. So I need to find the area to the left of that critical value. Okay, so p-value equals to normal CDF negative E 99 1.8335801. I get 0.96664. Now the p-value is significantly higher than alpha. So step 5, informal conclusion. My p-value is greater than. Is greater than. So we will fail to reject null hypothesis. So we support this one, we don't support this. Now, then how do we write the conclusion? Step 6, conclusion. At alpha equals to 3%, right? At alpha equals to 3%, there is, now because the claim is with the null hypothesis, we will try to reject. The wording will be to reject null hypothesis. Okay, that's what we want to do. But the sample data does not support it, right? That's why we come up with fail to reject. So we will say there is insufficient evidence to reject the claim that girls on average score at least 600 on the SAT verbal section. Our textbook actually used this phrase in this case. Our textbook used the phrase, there is insufficient evidence to warrant the rejection of the claim that blah, 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 blah. Our textbook tried to be super professional. And now that's not wrong about it. You know, sometimes to impress somebody, you need to use higher level vocabulary, right? Okay, but this is what I said here is actually appropriate enough to say that there's insufficient evidence to reject the claim. There is insufficient evidence that warrant the rejection of the claim. Or if you want to write it in simple way, so you see when I did the conclusion here, I did double negative, insufficient to reject. Insufficient to reject. Okay, I hope this phrase here reminds you to something. If you ever fall in love, then then you may say this to somebody, you know, I cannot live without you. Have you ever heard? There's a song, cannot live without, right? Okay, so it's not that I can live with you, it's more about I cannot live without you. So it's double negative there. Okay, now that's the formal, more appropriate way when your claim is with the null hypothesis. Now, but if you want the simple way, then you will just say that at 3% significance level, the sample data, does the sample data support or does not support the claim? Support or does not support? Hmm? So you see in step 5, we failed to reject null hypothesis. Okay, and the claim is with null hypothesis. Because we failed to reject, it means we support, right? Okay. Now that's for question 2. And again, let's compare to what we learned last week, when we use, what's that? When we use the word higher than. So what happened here? The claim is with the alternate hypothesis, okay? And you fail to reject null hypothesis. So what do you think the conclusion should be? The conclusion should be the sample data support or does not support. In this case, the claim is with the alternate hypothesis. But you do not reject null hypothesis. So the sample data does not support the claim. Okay, because again, the claim is in the alternate hypothesis. Okay, but the evidence, the data actually support the null hypothesis. Okay. Now from here, I will do more problems. Give me a second. Yeah, I have another file that I want to show you, but let me ask you to do this problem first. Give me a second. Okay, let me ask you to do this problem here. And this problem is not from me. I didn't write this problem. I actually went online, I do search here and there, and I collect problems from different universities, from different departments also, on how to conduct hypothesis testing. So this question is from University of Utah, from Electrical and Computer Engineering Department. It says the following: a batch of 100 resistors have an average of 102 ohms. So let's write down what we have here. So the sample size is 100. The sample mean is 102. Assuming a population standard deviation of 8 ohms, test whether the population mean is 100 ohms at significance level of 5%. So step 1, claim. I think the claim is pretty clear. Test whether the population mean is 100 ohms. It's quite straightforward, right? The population mean is 100 ohms. Hypothesis. From the claim. From the claim, you see the hypothesis, null hypothesis, alternate hypothesis. Mu is 100. That's the claim, right? Let me use red color instead. That's the claim. And the alternate hypothesis will be the complement, which is not equal to 100. But because it is not equal to, the test later on will be two-tailed test. Now to show that mu, to show that mu is not 100, we need to come up with a sample mean that is very different from 100. That is, you need to come up with either much higher than 100 or much lower than 100. Okay, much higher than 100 or much lower than 100. Okay, that's what it means to be a two-tailed test. You need to come up with a sample mean. Basically, you need to come up with a statistic that is much different from what the parameter. Okay, let me go on. You know what? Let me just leave that note there. Let me just leave that note there. Okay, step 3. What am I doing? Am I back here? Okay, step 3. Test statistic. Okay, the C-score, because we know the population standard deviation, is the sample mean 102 minus the claim mean 100 over standard deviation of 8, population standard deviation of 8 over square root of 100. Okay, the sample size is 100, right? So Z is equals to, that would be 20 over 8. That's 2.5. And step 4, the p-value. .5 is here, so the tail area is the area to the right. But the thing is, because it's two-tailed, you need to double it. Okay, because it's two-tailed, you need to double it. So p-value is equals to 2 times, that's because of two-tailed, 2 times normal CDF .5 E9901. That is 2 times 2 times 0.00621. I get 0.01242. That's the p-value. Then we see that the informal conclusion I think the alpha is what, 5%? Because the p-value, which is around 1%, is less than alpha, then the conclusion will be reject null hypothesis. Okay, so let's see. The claim, the null hypothesis has the claim. We will reject this. Okay, we'll reject it. Okay, now then what happened to the wording? Remember, if the null hypothesis has the claim, then the wording will be, we try to reject the claim. And because we reject null hypothesis, therefore we reject the claim, right? So at alpha equals to 5%, there is, we will reject the null hypothesis, therefore we reject the claim. There is sufficient evidence to reject the claim that the population mean is 100 ohms. Yeah, seems like 102 ohms on the sample average is just a little bit more. It's only 2 points more than what they claim, right? But it turns out this 2 ohms more is way too much for a sample size of 100. Okay, such that we will say that the sample data or the evidence, the sample data actually does not support that claim. Okay, a simpler way to say alpha equals to 5%, the sample data does not support the claim that the population mean is 100 ohms. Now if you don't feel the being annoyed with the technicality, if you don't feel annoyed by the technicality, then you don't see the purpose of writing it in a technical way. Have you ever heard that? I mean, you should have heard that term called political correctness. Strangely, if you do some survey, you will see a lot of people don't like to be to play with political correctness, but at the same time, we use political correctness to accuse somebody of being whatever wrong. Okay, so for example, let's say I may say, I don't like you doing this, right? Let's say I say, I don't like you doing something. Okay, now somebody else may use this sentence and call that hate speech. Now, I'm not saying you will, but some people may twist what you say and call that hate speech. Okay, simply because I say it not in the pattern that you like. Okay, so how do I say it then? How do I say it? Somebody may even rephrase that incorrectly, saying that I just don't like you, which is, no, that's not what I'm saying. Okay, my wife always say that to me, that I don't like you using phones when you're in the restroom. And trust me, everybody don't like you doing that, right? But you will not complain to yourself if that's what you are doing. As if I'm saying political correctness is a weapon you use against somebody else, but not to yourself. That's not fair. Okay. When somebody else saying things, they have to say it correctly, but then when you are the one saying that, you don't see the need of doing that, and you simply go back into saying, but you know what I mean, right? Okay. But you know what I mean. Now, the thing is, when you are doing a statistical report like this, you need to be politically correct. Okay? The thing is how I, as an instructor, needs to push it on you that you need to be quote unquote correct in your wording in conclusion. Okay? Now, the simplest I allow you to go to is using this wording here. The sample data support does not support the claim. Okay? But if you want to be quote unquote statistically correct, then this is what you're supposed to say. Okay, or some variation to this. We know in the end, deep in our heart, we may say that, oh, you know what, that person is BSing, right? But you cannot say that in public. You cannot even write it down, though. Okay, when somebody say, oh, the claim, the population means 100, I really want to say to this person, hey, you know what, you're lying. But no, we are not supposed to say that. Okay, we can just say that the sample data support or does not support your claim. There's evidence to reject the claim. Okay, nothing personal. Okay, it's not about you, it's about what you say. Okay, and what you say was population means 100. Okay, and the sample data does not support that claim. Okay, even though in my heart I may say, oh, come on, man, you make unreasonable, baseless claim, right? But still, I still have to say it correctly. Okay, so try this time with this quote unquote political correctness in mind. Try this time to apply that to yourself instead of applying to somebody else. Okay, before you expect somebody else to say it right, you yourself have to learn to say it right first. Okay, say what you mean what you say, plus say it in a nice way and accurate. Well, because when that person make a claim that the population mean is 100, that person make the claim about the resistor. It's not something to go against you, not attacking you. Why do you need to attack that person and saying that, hey, you know what, Thomas, you're lying? No, it's not about me. If I say it wrong, if my claim is incorrect, then just say so, but you don't need to attack me, right? Okay. Now, of course, as a teacher, I teach you how to be quote unquote statistically correct in you come up with your conclusion. Okay, but I myself, to be honest with you, in real life, I don't like this kind of BSing. When I come to conclusion, I need to be careful, and I say, yeah, to be honest with you, I'm not that kind of person. But that's me, person. Okay, that's me, not me as a teacher. As a teacher, I still have to do what I need to do. Okay, but if you know me in real life, yeah. Ask my wife. Okay, that's one. I'm about to give you a break, but let's see question number one from my handout, which I will actually post later. Let's see problem number one. This is from Boston University School of Public Health. Now, in 2002, the mean weight for men was reported at 191 pounds. Suppose that an investigator hypothesizes that the weight are even higher in 2006. So this investigator hypothesized that the mean is more than that 191 pounds in 2006. Now then, a random sample of 100 American males, so n equals to 100, in 2006 turns out to have an average of 197.1 with standard deviation of 25.6. Now the thing is, this 25.6 pound standard deviation is not population standard deviation. No, it is from that sample. Okay, so from this sample of 100, we get this sample mean and this sample standard deviation. Okay, so that's where you need to be careful, not sigma, but is S. Use 0.03 significance level. Now, what will the difference be here? Now, what we have before, if we are testing, hypothesis testing on mu with sigma known, we will use Z, right? Now, but what happens if the sigma is unknown? And we use sample standard deviation instead. Then we will use T. Okay, so you will see the difference actually in step 3 and step 4. You will see the difference in step 3. Instead of using Z, you will use T. And in step 4, when you do the P value, instead of you use normal CDF, you will use T CDF. Okay, that's where the difference is. So instead of, so the T later on will still be the sample mean minus mu over sample standard deviation instead of population over square root of n. Okay, that's the formula. Okay, now let me work this out. Number one, claim the weights are higher in 2006. I think I should say higher than 191 pounds. Hypothesis. No hypothesis, alternate hypothesis. The mu is greater than 191. That's the claim, because it goes to alternate hypothesis because it doesn't have equal sign. That's the claim, and we see this is actually a right tail because it's greater than a number. The null hypothesis, therefore, will be mu less than equals to 191. Step 3. Test statistic. T equals to the sample mean minus the claim population mean over sample standard deviation over square root of sample size 100. I get 2.38281. That's my test statistic. Now then, step 4, the p-value. It's a right tail, and this is a t distribution, not z. This is t distribution 2.38281. The p-value is TCDF. TCDF from the critical value to infinity, the test statistic to infinity, that's 2.38281, goes to infinity, comma, degree of freedom. This is the degree of freedom. Now, do you know where to find the TCDF? You should know that, right? TCDF 2.38281, and the right, the upper bound is infinity E99, and degree of freedom is 99 because the sample size is 100. So the p-value is 0.00954. I hope you see the difference. It's very, very similar to what we did before. The difference actually at step number 3, and it's basically just a notational difference. Instead of use Z, now we use T because of the change in here. And therefore, when we do the p-value, we don't use normal CDF, we use TCDF. Okay, but we are basically done with the difference. Now we go back to what we have done before in formal conclusion. The p-value is less than, right? P-value is less than 5%, less than alpha. No, hold on. 5% or 3? Oh, 3%. That's still less than. So the conclusion will be reject null hypothesis. Okay, and then conclusion. At 3% significance level, there is sufficient evidence to support the claim that the weights are higher than the weights are higher than 191 pounds in 2006. Okay, so you see this change only happened in step 3 and step 4. Let me give you a break together with one little work for you. Let me see. Problem number 3, NYU problem, School of Business. You know NYU have a well-known School of Business, right? Well, first, that's an expensive school. Okay, let me ask you to do this problem together with your break. Let's come back at 12:30, 45. Let's say 12:50. Step 1, we need to rephrase it because it doesn't have explicit claim. The claim, it was actually done in form of a question, but of course that's not a claim, right? So we need to rephrase this claim, this question into the claim. In fact, it's actually not appropriate to say, when we say the claim, that there's evidence of a significant change. What kind of significant change? So we try to be explicit here that it changed from 1,240 per month. Okay, and change about what? Change about the cost of maintaining cancer patients. Okay, that's for the claim, which I did for you earlier. Step 2, hypothesis. So the average has changed. So the mu is not equals to 1,240 anymore. So that's the claim here. And because it is not equals to, it will be two-tailed. Step 3, test statistic. Because the sigma is unknown, we will use sample standard deviation in place of sigma. Therefore, the test statistic will be T, which is 1080 minus the claim mu. From the null hypothesis in step 2, 1240 over 180 divided by square root of 15. Now make sure you know how to use your calculator for this though. 1080 minus 1240 give me negative 160. That's the one I divide by the quotient of 180 by square root of 15. I get negative 3.44265. Let me continue up here. The p-value then negative 3.44265, but that's a two-tailed, so I need to double whatever the area there. Okay, so p-value will be 2 times TCDF. Let me write it again as a warning. This is because of two-tailed. TCDF negative E99 negative 3.44265 degree of freedom 14. I get 0.00198, oh, times 2. Times 2, that should be 0.00396, which is still less than 5%. I double it, it's still less than 5%. So informal conclusion, notice that the p-value is 0.00 something, is less than alpha. So the conclusion will be reject null hypothesis. Oops. The formal conclusion, therefore, conclusion at 5% significance level, there is sufficient evidence to support the claim that, let me copy paste, that the cost of maintaining cancer patients has changed from 1,240 per month. Okay. Now notice that we did feel that the claim supposed to be has decreased. It's lower from 1,240. That's what we would like to say, but that's not the claim though. Okay, the sentence there clearly used the word change. So the change there doesn't have to be lower. Therefore, it becomes a two-tailed test. Okay. If we want to claim that it's lower, not only change, but even lower than 1,240, then when you do that kind of change in your claim, instead of has changed, you want to say lower than 1,240, then this becomes less than, and the claim, the alternate hypothesis becomes a one-tailed test. Okay, it becomes a one-tailed test. I believe the result will be the same, that the sample data support the claim, but you need to change the claim first before you come up to that conclusion. Okay, because your claim is about the change, then your conclusion has to be about the change. You cannot say in the claim that it has changed, but in your conclusion you say it's already lower than. No, that's not the test you did. Therefore, you cannot come up with that conclusion. Okay, so you claim one thing, your conclusion should be about that same thing. Okay, now let's summarize a little bit what we have learned. So we have learned when we test mu with sigma known, in step 3, the test statistic will be C equals to x bar minus mu over sigma over square root of n. And accordingly, our step 4, we will use p-value normal CDF. It's basically how to compute the area of the tail, because it's standard normal, then we use normal CDF. Okay, now what happened when we are testing mu with sigma unknown? Then in our step 3, the test statistic is no longer using Z, it will be using P. The formula is still the same, except that we change the sigma, we substitute the sigma by sample standard deviation. Okay, and likewise in step 4, the P value will be TCDF. Okay, the change are here, and here, and here. Okay, now let's see more. What happens if we are testing P? In confidence interval, when we did confidence interval, the critical value, we use Z, so the test statistic here will be Z also, which is P hat minus P over square root of P cubed over N. Okay, so I substitute my X bar by P hat, okay, and my sigma by P cubed. That's the change. Now, consequently, of course, step 4, the P value will still be normal CDF thingy. Okay. Oh, by the way, well, because we are testing P, then step 2 will also change, right? Step 2 on the hypothesis, and the null hypothesis, alternate hypothesis will be about P, not about mu anymore. Okay, that's the little change. Now, let's see problem number 4. We are now testing proportion. This problem is from University of Notre Dame, Department of Sociology. So we already have electrical engineering. We already have NYU Denver School of Business. What else? Boston University. This time from University of Notre Dame. The mayor claims that blacks account for 25% of all city employees. That's clearly the claim. Let me just do that right away. Claim. Remember, it's not about the person. It's not about the mayor. It's about what the claim that that person makes. Okay, black account for 25% of all city employees. Actually, I need to read the whole paragraph first, though. Now, a civil rights group disputes this claim and argues that the city discriminates against black. So the mayor actually claimed, the mayor says that the P is equal to 25%. The civil rights groups argues that the city discriminates against, as if they are saying, no, the P is less than that. Okay? So there are actually two claims here. They are not exactly complement of each other. So how do I know we need to test this claim test this claim instead of the civil rights claim? How do we know which one to test? Well, from the last sentence, it says test the mayor's claim, not test the civil rights group claim. Okay, test the mayor's claim at 5% level of significance. Okay, now let's see what we have here. A random sample of 120 has 18 black. So you will see P hat will be 18 over 120. That's 0.15. Okay, step 2. Hypothesis. Now it's about proportion, right? Hypothesis, the null hypothesis P equals to 25%. That's the mayor's claim, right? That's the claim. And alternate hypothesis is the complement of that. Okay, remember, this question may be treated differently by another teacher, but I try to be strict with the wording. The wording is test mayor's claim. It's not test the claim only, because there are two claims here and they are not exactly competing. They are not exactly complement to each other. No. Okay. Other teacher may say this is supposed to be P less than 0.25. But I disagree with that. It's clearly say test mayor's claim. Mayor's claim is it's equal to. So to say that the claim is not supported, you need to come up with P that is different from, not less than, not only less than. When we say different from, it could be more than 25%. Okay. As if I'm saying the following. Imagine if I delete this one sentence here. As if the question read, the mayor claims that black accounts for 25% of all city employees. A random sample of 20 city employees has 18 blacks. Test the mayor's claim at 5% significance level. We still can do that problem. Okay, because what? They tell us the mayor's claim, and that's what we need to test. So that's actually enough. Okay, how about the civil rights groups, Thomas? It actually doesn't matter here. It doesn't matter what the civil rights group says, because the claim that we are testing is the mayor's claim. Okay, now let's see. I want to erase this because that's not true. Okay, because it is not equal to in alternate hypothesis, then we know this will be two-tailed. Okay, let's see step 3. Hypothesis testing. I'm sorry, no. What am I doing? Test statistic. So C equals to P hat 0.15 minus P 0.25 over square root of PQ 0.25. The Q is 0.75 over square root of the sample size 120. So use your calculator. I get negative 2.52982. Please check using your calculator. Now I go on with step 4. P-value. So I get negative 2.52982 here. I need to find the area of this one tail and double it because it's a two-tail test. Notice that if you actually test the civil rights group's claim, then it will be a one-tail test. Okay, then it will be a one-tail test. And there could be a situation where neither one of them is wrong. In this case, you will see that the claim is not supported later on. Okay, but we are not dealing with it. It turns out that the civil, I think I need to emphasize this, the civil rights claim and the mayor's claim are not exactly complement to each other. The mayor says that it's equal to say the mayor's claim is incorrect, you need to come up with p hat much greater than or much less than. Okay. Then the p value here is, because it's two-tail, that's 2 times normal CDF negative infinity negative E99 negative 2.528,982.01. That's 2 times, let's see, normal CDF, negative infinity, lower bound, upper bound, negative 2.52982. I get 2 times 0.00571, which when I double, I get 0.01141. You may get 1142. That on my calculator is 1141. Now that's less than alpha, which is 5%, I believe. Now the rule of thumb is if they don't tell us the alpha, if alpha is not given, if the significance level is not given, then the default is 5%. P-value is less than alpha. So we will reject null hypothesis. Okay, and then step 6, conclusion. At 5% significance level, there is sufficient evidence See, the mayor's claim is null hypothesis, right? That's the mayor's claim. And we reject this. We reject that. So we will reject the claim. Okay, we'll reject the claim. So the way we say it, we will say that there's sufficient evidence to reject the claim. Of course, you can also say there's sufficient evidence that warrant the rejection of the claim that. Or if you want to play simple, you will say there is the sample data does not support the claim that black account for 25% of city employees, of all city's employees. Okay, let me ask you to take a look. While I look at the last question of the day. Let me do number 6. I skipped number 5 in my handout, which I will post later on, together with this. PDF for these notes here. Problem number 6. Let me ask you to try working on this first. Let's write down what we know, and then I give you a couple minutes to work on that. Maybe 5 minutes later on to work on that. Maybe, maybe I give you 8 minutes then. This problem 6, a new drug is proposed for the treatment of migraine headache. You can change this new drug into the COVID vaccine, and you use this. Okay, you use this testing here. Okay. Fortunately, some users in early tests of the drug have reported mild nausea as a side effect. Now, the FDA will reject the drug if it thinks that more than 15% of the population would suffer from this side effect. Okay, in an experiment to test this side effect, 400 people who suffer from migraine headache receive the new drug. So the sample size is 400, and 80 report this side effect. Okay, will the FDA reject the drug? So they don't tell us the alpha. The alpha then will be 5%. If no alpha provided, then use alpha equals to 5%. That's the default. Okay, now step 1, the claim. What's the claim? There are many possible claims here. FDA will reject the drug. Actually, I prefer to say that more than 15% of the population would suffer from this side effect. Okay. The second one is the preferable. And the first one is acceptable. Because literally, wording wise, explicitly, that's what we want to, that's the conclusion we want to come up with. Okay, will FDA reject or will not reject the drug? Okay, but it's more about the context here. It's more about is it because of this 15% population suffer from this side effect? Okay, more than 15% suffer from side effect. It is possible that less than 15% suffer from this side effect, yet the FDA still reject the drug for other reasons, right? So the claim that I use here, I prefer to use the second one because it's more contextual. Okay, now I would like you to go on with step 2, 3, 4, 5. 2, 3, 4, 5. Okay, let me give you 8 minutes. So hypothesis, null hypothesis, ultimate hypothesis is about p greater than 0.15. So the alternate hypothesis is the complement. The claim is with the alternate hypothesis, and therefore it is a right tail. Step 3, test statistic. That is z equals to p hat. What's my p hat? That's p hat equals to 80 over 400. That's 0.2, huh? Yeah, that's 0.2. So 0.2 minus 0.15 over square root of p, which is 0.15, q 0.85 over 400. So now let's enjoy our calculator. I get 2.8 something. So the p value 2.8 something is here. This is the area. P value is normal CDF 2.8 E99 01. I get 0.00255. Informal conclusion, because p-value is less than alpha, then we will reject null hypothesis. And step 6, therefore, will be at, is it 5%? Yes, I remember it's 5%. No, it doesn't say anything, huh? Well, then alpha is 5%, right? At 5% significance level, there is sufficient evidence to support the claim that more than 15% of the population would suffer from this side effect. I will stop here. Your suggested homework will be from 8.3, number 9, 11, 13, 15, 17, and then 21, 23, you need to find X bar and S yourself. And then on 8.2, number 9, 13, 15, 17, 19, 25. Okay. Now, if you have a chance to watch the continuation of this lecture video, the one I told you, which I will post the link also on the discussion board. Then, if you can watch Summer 20, Math 227, West LA College, July the 22nd, I think 20th, and then the 22nd. Then you will see, try to do 8.4, 7, 9, 11, 13. Okay, but 2 weeks later, when we start the class, I will start with that 8.4 and also chapter 9. Okay, that's for today. See you then in 2 weeks. The last day to drop the class, I think, is tomorrow. The last day to drop the class, I think, is tomorrow. Maybe Sunday. I don't remember precisely, but I will try to grade your tests as soon as possible, so that I can post the grade. You can see your average. But if not, then you need to decide yourself if you want to keep this class or you should drop this class. Okay. Now, but the burden is actually on your side, so don't. Okay. I only provide you information if I have a chance to finish grading earlier. Okay, then that's for today. Bye bye.
Thank you.
You're welcome.